this is what I'm trying to explain. I'm saying that in C programming, everything is modularized. Okay, you cannot just start writing a program and then declare anything, hanging in the air. Everything is contained. So I cannot come in this program and say that 1 plus 1, like 1 plus 1 equals to, no, like what is a 1 plus 1 inside? Everything must be inside something. This is the purpose of declaring variables, so that our data types can be contained in containers, because we cannot leave them hanging around. And that is the purpose of variables. Very simple. And if you look at this carefully, you're even going to realize that everything that you write in C is inside this main function. So the basic structure of a C program, you realize that what happens is that you write your int main, then you bring these curly braces, and then a lot of your codes go in here. Okay, so that is a modularization I'm talking about. When you go into the standards of coding, industry standards, they'll tell you that before they give you a job, you must know how to write modularized code. That means that everything must be contained. That is very important. So in talking about variables, there are local variables and then there are global variables. For instance, if I come here and I say that who is Galileo in this class, everybody will say that, okay, Galileo is Galileo Boating, because in the confines of this class, we are only about less than 10 people here. Okay, but we know Galileo in this class, so this is the local Galileo. But then globally, we know a certain scientist who lived hundreds of years ago called Galileo, and he was an astrologer, he was an astronomer. He came up with scientific concepts concerning astrology and all, and he's a very popular man globally and internationally. So when we say Galileo in this class, we're referring to our Galileo Boating. That when we say Galileo, when I step out of this room and I go and stand on the street and I say Galileo, everybody knows that I'm not talking about this Galileo Boating. Nobody knows him, unless maybe one day he becomes like a very famous man. But for now, the Galileo we know is a scientist called Galileo. All right. So when you are declaring variables, there are those that are called local variables, like Galileo Boating. Oh, Galileo says he's a scientist. We celebrate you, brother. All right. So now, yesterday, I was teaching you guys and I told you that this is a basic structure of every C program you ever write in your life. Even if the details change, this will always remain the same. So anytime you're about to write a C program, write this. Include your header file, int main, leave it this way. Then you can now make the changes and attach things to it. For you to declare a local variable, you declare it inside a function. So this int main you see over here is a function. It's always there. Now, if I want to declare a local variable, I want to declare the age, my age, or the age of anybody over here. So what will you do? Like I taught you, bring the data type. My age is an integer, so int. Then the way you name your variables, you have to make sure that your variables are very descriptive. So I want to use age. This is the name of a variable, and I can either end it, and then I'll come and say that this age that I declared equals to 30. You see, I've declared a variable right here. Just give me a moment. Let me set the syntax so I have a nice colored output. Okay, good. So now realize that I declared a variable here, int age, and then I came down. I came to say that my age is 30. But you can also choose not to do that. You can just come and assign a value to the variable directly. So I can say that int age 30. I've assigned the value 30 to the variable called age. So in this context, age you see over here is a container. So then the value 30 is inside age. That should make a lot of sense to you. So this is what I mean. Just a moment. I think I've magnified this too much. I'm having challenges with my sketchboard. Good. Great. Now I see my pencil. Okay. So the container, which is the variable. So this is the name of the variable age. Then inside the container, we have the value 30. This is the syntax of variables. All right. So the container is a variable. That's the name age. And inside it, we have a value called 30. And inside the computer's memory, there's an address for this container. So let's say that I have gone to Accra and I have gone to put this container at Kaswa. Okay. So the address of this variable is at Kaswa. All right. I can create another variable and I'm going to call it maybe your name. Okay. And your name is Ernest. And I can go and place this box at Latebi Okoshi. Okay. So there's a reason why I'm telling you these things, because you need it in solving some of the questions that you've already been given. We are going to solve them today. No. The time is currently 7:40. So I'm going to be using about 20 minutes to brush up the concepts. Then for the remaining hour, we are strictly going to solve questions, so that in solving the questions, you have an idea of how to use the concepts. Okay, so number one, the container is a variable. The value in the container is the value of the variable, and every variable has an address in the memory of the computer. Let us stay with you, and that is very simple to understand. And I also explained to you that there are local variables and global variables. And to declare local variables, you declare it inside a function. So this thing you see over here is a function, and this variable you see here is a local variable because it is inside this function. this is the container of the function, these two curly braces. So this variable is a local one. If I wanted to declare a global variable, then I have to come out of the function. Then I can declare, let's say, a float, okay, because I've been using int all the time. So let's declare a float and let's call it my grade or my GWA or something, my GWA. And then let's say that my GWA is 3.8. So I've declared a global variable outside of a function. So now what happens is that if I come into, when I come outside of this int main function, this variable won't exist. So I cannot use the age variable as long as I'm outside this function. So I cannot come outside this function over here like this. You're going to understand this in a moment. I cannot come here and say that age plus 1. No, it's not going to work. It's not going to work because this age variable is inside the int main function. So the moment you come out of it, it's not recognized anymore. But over here, I can come and say GWA plus 1 because this is a global variable. It can be recognized throughout the code. Everywhere you are standing in the code will recognize it because it's global. But for the local variables, it only works, it can only be recognized inside here. So I wanted to say age plus 1, I would have to come inside here. And I'll say age plus 1 so that it can be recognized because it's inside this function. Very simple and straight to the point. Now we have everything we need to know about variables. So let's go and talk about data types.
Please, can I say something? If I understand what you just explained clearly, does that mean that global variables can be easily modified than that of the local variable?
It really depends on the kind of code that you're writing. The danger with global variables is that when you declare a global variable and you have used it throughout your code, the moment you modify it, it's going to affect every place you have used it. Do you get it? But when you use a local variable and you modify it, then it means that the modification is only happening within that function. But then if you use a global variable and you have used that variable throughout your code, and you're now going to make a modification to that global variable, every modification in your code will change. That is how come we scarcely use global variables. So if you go through some of the ALX requirements, they're going to tell you that do not use global variables. You're going to be seeing that a lot because ALX, like I told you, wants to make things difficult to be able to train us. All right. So it's one of the most commonest things you're going to see in codes.
Thank
all right.
you.
You're welcome. So if there are any if there are any questions on variables, go ahead and ask before I move on.
Yeah, so for local,
yes.
Variable, it means that you could train a lot of them.
Oh, you can you can declare 1,001 of them.
So they have to be in different functions.
They have to be in different functions. They have to be in their own functions. Okay. You can
if you have a lot of them to declare, it would be more advisable to use global so that your code will not be confused.
It really depends on what you, like I said, depends on what you are trying to do. Sometimes the function that you are writing, let's say you're trying to calculate the factorial of a number. That means that you have to take the parameter inside that function. We'll come to that. So with that one, the variable shouldn't be global. It's something, it's like I'm trying to cook soup, and then I have the ingredients that I'm going to use to cook the soup on my table. So for this particular food that I'm cooking, let me stay within the confines of this kitchen and use the ingredients within this kitchen. But then why would I go to the kitchen at the market? I mean to the market and go and take ingredients to come and use them in my kitchen when I have ingredients in my kitchen. So I have tomatoes here, but I'll go to the market and go and get more tomatoes to come and use to cook. No, it's making my work difficult. So let me stay in this kitchen and use the ingredients that I have over here. But then if I want to use, I need more resources, then I can now go to the market and go and get more resources and come and add to my ingredients. So as long as you are in a function and you need the function parameters and then the variables of that function, stay local. Don't go global, stay local. And then use the local variables.
Once again, what is the difference between the function scope, which is the local variable, and the block scope? Since they are all within the curly braces, what is the difference between the two?
So now, this is, let me go to my sketchboard and make that very clear to you. Okay. So now let's go to, realize that you can have functions within functions. Okay. Great. Nice. So now, this is my simple C code. So I'm going to include whatever I need to include over here, blah, 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 my header file. Then I come to int main. Then I have this main function over here. Now, like I told you, int age, this is a global variable. Okay. Now, inside my main function, anything I declare in the main function automatically becomes local. However, inside the main function, you can also have more blocks within it. So watch this. I've not come to control flow yet, but because of the question you asked, I'm going to use that just to make you understand the block scope. Okay, so let's say I'm in my main function now. So every variable I declare in here is local. However, I can have a block scope variable. So I'm going to say if 1 is less than 9, and I open another block within the main function. Okay, then I'll declare a variable int n equals, let's say 2. So this n you see over here is a variable. Okay, but that variable is inside these curly braces. These curly braces you see over here. So this n, which is a variable, is inside this block. At the same time, it is also inside the int main function. Okay, so this n you are seeing over here is local to the if statement, but it is not applicable when you come and call it outside these curly braces. So let me use another color for that. So I'm going to use yellow. Okay, so everything looks. So I have these curly braces for the main function. Then I have these green curly braces for the if statement. So this n variable over here is not applicable when I come and say n plus 1. In the main function, this variable will not be recognized because it's only recognized in these curly braces. So that's a block variable. However, both this n and any variable I declare within the main are still local variables. Does that make sense to you?
Okay, so does that mean that it is only when we are working with if or loop statements that we can use the block codes or the block scope?
No. You can use them in if statements, you can use them in control flows, you can use them in dual loops, you can use them in functions, because there can be nested functions. Okay, you can have functions within function. You can use them in function calls. So it's not only in if statements. There are various applications you are going to see through which you can use the block scope variables. Does that make sense to you? So don't worry, we are going to solve. There's this particular question that I want us to solve. It's one of the advanced tasks. There's a reason why we are going to solve that question today, because you are going to have to apply everything we have learned to be able to solve that question. So instead of worrying ourselves with the initial questions, I want us to go and solve one of the advanced tasks. Then we'll try and solve so that all the concepts that we have been studying all this while, we'll put them to use to be able to solve that question. So that's it for variables. I'm moving from variables and I'm not coming back to variables again. So if you have any question on... Sure.
For example, that you use
yeah.
Realize that you use a fixed age.
Yes.
In an instance where you have to admit different ages in
a variable.
That variable. Right.
Yes. So this is what I told you. A variable is a container for a single item. As long as it's not a single item, you cannot call it a variable. So we have a container which contains an apple. Okay. As long as you add another object, then you are into something else. You are out of the scope of variables, because variables contain single element. So let's say I want to put several elements in one variable. Then that is what takes you into what is known as arrays. Arrays, A-R-R-A-Y-S, arrays. And the interesting thing about arrays is that you can declare one variable and put 1,001 objects in it, as long as the objects are of the same data type. We have not come to arrays yet, but because of your question, it's the same thing as variables. So we might as well talk about it. So let me reduce my pen density. Let me just say 3. Okay. So the way to declare a variable is int, then the name of the variable, let's say age. Then you assign a value to that variable. But there is something called arrays, because now this time around we want to keep several objects in one variable. And the way to do that is to bring the data type. So int age. Then you bring something called a square bracket. So you bring the square bracket. Then you now tell your computer that, okay, in this variable, I want to keep 20 items or 10 items or 5 items. So now I'll say that, okay, I want to keep 5 ages in this variable. So I'm going to come and say that it's equal to, then I'll bring curly braces and say 1, first age is 1, second age is 10, third age is 14, fifth age is 3, 1, 2, 3, 4. Yeah. And then the final age is, let's say 7. Then I close my curly braces. So you realize that in this syntax, I have been able to store several elements in just one variable. So if you want to store several objects in one variable, then you are not dealing with variables necessarily, you are dealing with arrays. You are dealing with what is called arrays, which can contain several objects of the same data type. I'm emphasizing on the same data type because you cannot store different data types in an array. So I cannot come and say int, which is an integer for whole numbers. I want to declare ages, and let's say I want to keep 5 ages in this array, and I come and say it is equal to 1 and 7.5. The moment I bring this, we are in trouble. The program is going to read an error because I said I'm declaring integer data types. If I wanted to use decimals, then immediately I'm going to change the data type to a float. and I'm going to say that I'm going to declare a float of ages. Then I say, let's say I want to keep 3 ages in this array. Now I'll say it's equal to 1.5 years. I bring my comma, and I say 1.0 or 30 point whatever. So as long as I say a float, the data types of the constituents of the array must always remain the same. I hope that makes sense to you. But we have not come to arrays yet. But even with this little explanation, I think I've done the introduction of arrays. This is what arrays are about. But we'll talk more about arrays hopefully today, if we're able to get more time. Does that make sense?
Yes, please.
Exactly, a single number. You can't go beyond it. Let me share this notebook with you guys in the chat box so that
what? Let me give you an example. The call will terminate and I will have to raise hand.
Oh, okay. Your call will terminate.
Yeah.
Okay, no problem.
Oh,
you mean you are the one who started the Google Meet? If it terminates all of us are not gonna go off, but you will go off and then you rejoin, right? That's how it's gonna be.
Oh, if it terminates, I think we won't go off.
No, you're the one who's seen it, but we're not gonna go off. You can rejoin it. Okay. Yeah. Okay. So we won't go off, don't worry. Have faith. So I'm just gonna copy this and share it with you guys. Then while I make the edits, you're going to see it appear. You can take your time and also read it later on after this class. Okay, so I'm leaving variables. I won't come back to variables again until we have to use it in solving questions. Okay, so if you have any questions on variables, not now. I've left variables. I'm moving to data types now. Okay, all right. So bye-bye to variables. We don't have a lot of time. Okay, we have 4 minutes to 8 o'clock. No problem, no problem. Let's go and talk about data types. You guys already know how to comment in C, right? No stress about that. Don't just go and read about it. We've spoken about variables. And you can also assign multiple variables at the same time, okay? I'm going to show you how to do that. It's not complicated at all. To assign multiple variables, all you have to do is to, let's say I want to assign a variable of, so I can say int age, comma, what? Height. But then remember that if, exactly. So if you say the height you want to declare is an integer, that means that you can't use decimal numbers. But if you wanted to use decimal numbers in addition to this, then you rather have to say float. Then you bring your age and height. So that means that you have declared 2 variables at the same time. You have not assigned values to them yet, but then you have created 2 containers. So 2 empty containers that you can put object in. So that's a way to declare multiple variables at the same time. Very simple. But in programming, I usually advise that if the variables are not more than 3, then declare them individually. And there's a reason why. Very advisable. If you are declaring, let's say 5, 10 variables, then it means that you can do it at the same time to save time and space. But if you are declaring less than 3 variables, always declare them individually. So int aim, int age, int whatever, int on different lines, so that your code will look very neat. Yesterday I explained that there are 3 main kinds of data types. Okay, number 1, there are the integer types. Number 2, there are the floating point numbers. And number 3, there are the derived data types. Number 1, integer data types. Number 2, floating point numbers. And number 3, derived data types. Then for the integer data types, yesterday I only spoke about them and mentioned them roughly. But then today I'm going to go into details to show you something very important because we're going to need it in solving some of the questions. Every data type has a size, and then every data type has a value range. So number 1, let's use the one we are already familiar with, which is the int. We've been using it all this while, so you're already familiar with that. The integer data type has a size of 4 bytes. So every integer data type has a size of 4 bytes, and then this is a value range. See how big it is. So you can go from negative 2,147,483. Hold on, it's actually not 2 million, it's 2 billion, negative 2,147,483,648 to the positive of the same figure. I'm tired of mentioning it. I'm not going to mention it again. It's too long. So imagine when you say int, and you bring a certain name, age, that integer, you can put in any value, you can assign any value of between the range of all the ones you see down there. So you can imagine, so if I say int age, I can come and say that age is equal to 2 billion, blah, blah, blah. I cannot mention that number again because it's too long. So now, watch something carefully. If I come and I say that my variable is an integer data type, that means that I can only stay within the range of these values you see over here, from negative this to positive that. If I come and declare a value which is even 1 single digit ahead of this one, the code is going to read an error because the range of an integer data type is between negative 2 billion whatever to the positive 2 billion. So anytime you declare a data type, you must at all costs stay within that range. And you are going to think that, as for 2 billion 147 million, it's like how in the world can you even go beyond such a figure? But I'm telling you, you're going to see right now that you will always, this figure is too small in programming. It is nothing. This figure is too small in programming, and the reason why they brought the other data types is so that it will make room for larger and larger values. So now watch this. Among the integer data types, we have another one called long. Look at long, and long has a size of 8 bytes. Now the 8 bytes has this value range. I'm sorry, please, if you can mention it, you can help me, because I don't know how to mention this number. But if you look at the characters of this number, it ranges from -9, whatever this is, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17. It has about 18 from the negative side to the positive of the same number. So that is a long data type. So I can come and say that, okay, I'm going to declare data type. This time around, I don't want the int. I want long. I want to declare my money. All right. And I say that the amount of money in my bank account is negative, is positive, never negative. God forbid. Is this figure. So I can say that my money is this figure you see right here with a long data type. But the moment I go one digit outside that figure, the code will read an error. So all I'm trying to explain to you is that every data type has its value ranges, and it has a size in the memory of your computer. Does that make sense? Do I have people here? Great. All right. So
Yes, sir. That's
great. Now, there's one more thing I need to explain to you. We have the on. Yesterday I mentioned it, but today I want you to see it. We have the unsigned of every data type, and we have the signed of every data type. The moment you see unsigned, just know that we are dealing with positive values. So look at this character data type. The character data type has 1 byte, and then it has negative. It holds negative 128 to 100, positive 127 values. All right. But the moment you come and say unsigned car, that means that you cannot go into the negative. You're only dealing with positive values, and it ranges from 0 to 255. Then we have another data type as part of the integer data type. So all these you are seeing are integer data types, but they are variegated versions of the integer data types. Okay, we have the short. The short holds negative 32,000, blah, 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 to the positive range. Then we have the unsigned short. Okay, then that one holds only positive to 65,000 and something. Then we have the unsigned integer. The moment you hear unsigned, I told you only positive values. The unsigned integer can hold 0 to this value, which is very low. And then we have the unsigned long. The unsigned long is also 8 bytes and can hold whatever this value is, which I cannot mention. So the reason why I brought you here, is that I want you to see that the data types have value ranges that they can hold. And the one that can hold the highest value is which one? The unsigned long. And that one holds 8 bytes. So if you want to be in the safest ranges, especially when you are working with huge numbers, there's this program that I was writing. That was like a month ago. The program calculates the factorial. Just for those of you who are a little mathematically inclined, the program calculates the factorial of a number. And I was trying to do it and it wasn't working. That's because I had declared an unsigned int as a data type, but the values that were coming in were crazy values, which were in their trillions and zillions and whatever those things are. The value had like 19 characters or so. But then the data type I had declared was not sufficient to hold that much number. So I tried and tried. The program wasn't working until later on when I took my time to debug. I realized that the problem was with the data type I had declared. So now the data type I now had to come and declare to solve the problem was unsigned long. I know you don't see that one over here, but that one is also another data type which has not been written in this screenshot you see over here. So there's another data type called unsigned long. If the unsigned long can contain this many values, then how much more the unsigned long? That is too much. As a matter of fact, they didn't write it here because I don't think they'll have space for it. But the funny thing is that even after I used the unsigned long, some of the later values didn't have space. I'm telling you, amazing. That means that the values were really large. So this advice is to let you know that whenever you are dealing with very large values, your data type choices are going to be unsigned long or unsigned long, for you to be on the safe side. That is if you are dealing with only positive values. But if there are negative values in your data type, then that means that you cannot use the unsigned. You can only use long, so that you contain both positive and negative values. I don't have a lot of time today, but later on, I'm going to explain to you why the need for unsigned data characters, only positive values. But just to explain that in a statement, there are days that you'll be working on some calculations that will require only positive numbers. So in order for your code to be very efficient and correct, you want to use a data type that will only accept positive numbers, so that if any negative number comes in, it will read an error, so that your code can be very efficient. Just by the way. Now, that's the integer data types. Then now there is the double and the float as the floating point numbers. Remember I told you that there are the integer data types and then there are the floating point numbers. The floating point numbers are the double and the float. Those are the floating point numbers. And yesterday I explained to you again that there is something called format specifier. Okay, the format specifier has its syntax that you can use to print a variable, and we are going to come to this. Integer takes %d, double takes %lf, float takes %f, character takes %c, and if you are printing a string, it takes %s. A string is a kind of array. That's why you see these square boxes over here. We're going to talk about these when we are solving the questions. But then that is it. So this place over here, I give a few examples. You want to print a float, then you go a double, you go %lf, then you bring the variable name. If you want to print a double, you go percent. If you want to print a float, you go %f and you bring the variable name. We're going to come to these later. Okay, now, so I'm going to talk about double and the floating point numbers, their range. Okay, I don't really remember the range, how much decimal places the double and the floating point numbers take. But, so let's go online. Hello. Can you guys hear me?
Yes, we can.
All right. Sorry about that. I think what he said was true. His link actually went off and we all went off. I don't remember at what point you went off. You got the link cut because I was actually talking. I didn't know it had gone off. It was later I realized.
I think it allows for 1 hour and it goes off.
Oh, I see.
Yeah, and unless of course you are on a premium.
Oh, I think I understand it now. That's why other people choose Telegram. I now understand. So where did I leave off? Okay. So taking you back to my other notes. So just like I was saying. So you were in when I spoke about this, right? And then were you in when I spoke about the data type, the format specifiers?
Yeah.
Great, you were in. So then right from the format specifiers, every data type has its format specifier. So I was going ahead to talk about the double. The double and the float print decimal numbers. Okay, so you can see that if you use a double, that means that you have a room of about 1, 2, 3, 4, 5, 6 decimal places. So I wanted to be sure of the range of a double. Okay, so I took you guys to ChatGPT and I wanted to find out that, let me magnify this so that we see clearly. What is the range of a double and a float in C? The reason why sometimes I like to do this is so that you see the learning process. Okay, so in C program, the range of double and float data types can vary depending on the implementation and the platform, blah blah blah. However, the generally adhere to blah blah blah. The float data type is single precision floating point type. Typically occupies 4 bytes, no doubt. And then it ranges from -32 times 10 exponent 38 with precision of about 6 decimal places. So you see that with the float we have 6 decimal places, and with the double we have 15 decimal places. So that is the range of a float and a double. So if you are calculating something that says that bring all the decimal places to 15 decimal places, and you have to go for a double. But if you want how many decimal places? 6 decimal places or less, then you can use a float. Very simple and straight to the point. So that's it about data types. Yes, go ahead.
Show the data types. Some put this. So say for you to just put int and be within the range of int, could you just put a multiplier, say
double,
say
unsigned long,
yes.
So that you don't have to worry about range.
Yeah, just say you're not worried about what the range you're putting.
Now this is a problem. I'm going to show it to you. This is a problem. Memory. So the problem is that you're going to have a lot of garbage value in your code. This is a problem. Memory. You are going to declare an unsigned long. That means that you are taking 8 bytes of memory. Remember, you might be writing a program that has to be very fast. You're writing a game program. The moment you open a game, Grand Theft Auto or Mario, you don't want to wait for the 5 minutes for the game to load. Okay, so you are opening a website. One of the things I hate most is when I open a website and I have to wait for 1 minute for the JavaScript to load, for the website to load. I'm like, this website is too slow. So one of the important things as a software engineer is that your code should be fast. If you're supposed to do something with a character or an integer that's supposed to take small space, and you have gone to declare an unsigned long, you have allocated a lot of memory for something which should take a small space. So now the program is going to have a lot of drag time. So if it's not very and absolutely necessary to give it a lot of range, then stay with a small range, because you're fighting against number 1, speed. You're also fighting against memory allocation. So I'm going to put a cup of water in a container, and I'm going to carry a big drum. Then I fetch a cup of water and I put it in a container. Like I've wasted a lot of space and I'm not using it. So that's a problem. But if I want to store a volume of water, which is like a cup of water, I just need a cup so that I can have a small space and have a lot of room to do other things. So basically that is it. The problem you're going to have if you want to declare an unsigned long for everything is that you are allocating room, too much room for things you're not going to use. And it's going to tell in the speed and effectiveness of your program. Please, I hope that makes clear. That is very clear.
Yeah, it's awesome.
Yeah. So that is the reason why, you see, scientists are smart people. So you're like, okay, if we can use the unsigned long, why have you created int when it's smaller than the unsigned long? You could have just created the unsigned long and forgotten about the others. But no, they know that when you use the unsigned long, you have allocated more memory. Especially when we come to talk about arrays, that's when you guys will really understand the importance of this. And when we also talk about malloc and calloc and realoc, we'll come to there probably in our next meeting. I'm sure in our next meeting we'll have gotten there, because tomorrow too we are going to meet in the evening. And tomorrow I'm going to carry you all the way to pointers and arrays so that by next week we are up to date. Okay, so now we do malloc and calloc and realoc, you're going to realize that you cannot just declare any data type of your choosing for the sake of efficiency. All right, so now I'm done with data types. I'm not going to come back to data types again until we are going to apply it. And the last thing I'll say about data types is that there are other kinds of data types. They are not necessarily data types, but they are, listen to this, they are derived. Okay, so apart from the integer types, which contains the int, char, unsigned int, short, all those are integers, and then there are the floating point numbers, which are float and double. There are also another kind of data type, which are known as the derived data types. You're going to meet them, but we have not come to them yet. The derived data types are what is known as pointers. So you have been hearing pointers. Pointers. What is a pointer? It's a derived data type. Then also we have arrays. What is an array? It's a derived data type. Then we have unions. What is a union? It's a derived data type. We have enumerations. All these, we are going to come to them in the future. They are also data types, but just that they are built upon the data types you already know, which are the int, double, float, char, unsigned, and signed. It's very simple and straight to the point. So I'm done with data type, and I'm not going to come back to data types again until we are going to apply it in solving a question. There is a reason why I'm doing that, because we have to move. So I've done variables, I've done data types. Now I'm moving to control flow. Let me move to, no. Let me move to operators first, because I have a list here I'm following. Let me move to operators. Then I'm going to move to the control flow. So let's talk about operators now. Operators in C programming. So I'm just going to get out of here. We are going to talk about operators. Very simple. Operators are very simple. Very, very simple. You don't have, we are going to finish in 10 minutes, because it's one of the simplest things. I don't think anyone here has not done core maths. We have all done core maths. So we are going to finish it in 10 minutes. There are several kinds of operators, okay? There are arithmetic operators, which we are going to use right now. There are, make this a little big. Let's go 48. No, 64. No, that's too much. Let's go 48. Let me go and check if you guys are still here, so that what happened to me the first time will happen again. Yes, you are here. The first time I was talking like 10 minutes and you guys were gone. All right. Okay. So, all right. So there are 6 main data types. Operators in C programming. You are not going to need this right now. So forget about bitwise operators. Forget about the miscellaneous. Forget about the assignment. We are going to focus on 2 main operators for today, because that's what you're going to need for the foundation. We're going to focus on arithmetic operators and logical operators. Only those 2. That's all you're going to need for today. Now let's talk about arithmetic operators. 1 + 1, 2. 2 - 2, 0. 2 × 2, 4. 10 divided by 5. Simple. Now, so all those ones you know. But for the operators, I'm not going to talk about the ones you know, 1 + 1, blah, blah. Let's talk about the one that is a little technical, that you will need. And then we are going to use that to answer questions. So we're going to talk about 3 kinds of operators under C programming. And they are, number 1, the modulus operator. modulus. The modulus operator. And that is when you see this % sign. It's known as the modulus operator. And it's very simple. It's just like division, long division. So let's divide 3. Let's do long division. 3 by 15. 3 goes into 15 how many times? 3, 5, 15. And then our remainder is what? 0. So the modulus operator gives you the remainder of your calculation. So this simply means that 15 modulus 3 is equal to 0. Simple. Very simple. There are no 2 ways about it. J no copy, few copy, small, very small. Okay, now let's do something else. I want to show you something. Okay, let's do another calculation, then I'll come and show you what I want to show you. So let's do 17 modulus 4. Now someone should unmute and let's solve this one. If you don't unmute and solve it voluntarily, I'll call names. So someone should unmute and let's solve 17 modulus 4. Anybody at all should unmute and let's solve 17 modulus 4.
Okay.
Okay.
So 17 modulus 4, it's 1
Why is it 1? Help me out.
because 4 is divisible by 17 4 times.
4.
The 1.
So 4, 4, 16.
Yeah.
Then when we do the subtraction, we are left with 1. So the modulus operator gives you the remainder. So 17 modulus 4 is always going to be 1. Congratulations. Thank you. You understand modulus. Who spoke?
Nishira.
Ishira. Wonderful. Tomorrow, no, not tomorrow, today, I'm going to do a giveaway of 100 Ghana. When we get to solving some of the questions and then you're able to come up with the answers, the one who will be able to answer a certain question, I'll do a giveaway of 100 Ghana. 100 Ghana is not money that, I mean, it's not too much, but at least you have some money for dinner this night, or at least tomorrow morning, you can go and chill small. All right, so I'm going to do a giveaway of 100 Ghana. 100 Ghana no be money right here. Right, the 100 Ghana no be money for Ghana. Ah, 100 Ghana go finish right there. Okay, now, this is what I want to show you. Any number, now you need to hear this carefully because you use it 50% in ALX. You use it so much. Like, if I say 50%, that's an underestimation. Let me say 70%. You're going to use this principle I'm about to teach you 70% of the time. So you need to bring your ears here. Any number, no matter how big it is, as long as it's not a decimal number, any number modulus 10 will give you the last digit of that number. No matter how big it is. Any number modulus 10 will give you the last digit of that number. So let me write any random number. 7, 4, 6, 8, 3, 9. I'm not even thinking about it. All right, I'm not thinking about it. But then when I do this number modulus 10, what's the answer going to be? Anyone can unmute and tell me.
9.
Why is it going to be 9? I'm waiting for explanation. Why is any number modulus?
If I can help.
Yeah, go ahead. Go ahead.
Okay, so you know that for the number displayed, the last 10, the 10, I'll say the 10th is the 30. So 30 in the 9, that's it. So the 10th place before the 1. So it's in 10, you know, we have thousands, hundreds, 10.
That's right.
Yeah, exactly.
Very simple. Very simple. There's this Indian guy that I love so much when he's teaching. He goes like, very simple, very simple, very, very simple, no problem, no problem, very simple. You see, any number modulus 10 will give you the last digit of that number. So ALX will come and tell you that write a function that calculates the last digit of a number. Like, without thinking, you know that you're going to use modulus 10. Anytime you see write a function that does something last digit, don't think twice, it's modulus 10. It's like it should be the water you drink. You're going to be using modulus 10 a lot because there's a mathematical mystery about modulus 10. There's another mathematical mystery about modulus 9, but that's for advanced maths and elective maths. But for our level in core maths, know that modulus 10 is going to be coming up every day because any number modulus 10 gives you the last digit of that number. So if I go 17 modulus 10, it's going to give me 7. Just don't think. Just go for the number and bring it, the last number and bring it. Now let's talk about one technical one. Let's go for single numbers. So 3 modulus 10 is going to be what? Anyone can unmute and then answer. What is 3 modulus 10? Who said 1? That is not correct. Anyone can answer that question. What is 3 modulus 10? It means that, let me just make some space over here.
Zero. I think it's 0.
I think it's still 3.
Who said 3?
Yeah.
Shira, you're good, oh. You're good. You're good. No, wait.
That is correct. Because we are divided. I know I'm about to answer the
Yeah, go ahead. Go ahead.
The principle of the modulus. That is,
oh, you're breaking up. Am I the only one who is?
the modulus value.
Say what you said again. You were breaking up.
Is it clear now?
Yes, very clear now.
Yes, that was like the principle of the modulus. But remember, we want to divide.
Thank you. Thank you.
But remember, it's the modulus value. And here, 3 and 10, 3 and 10, 3 times, remember 1. And that should be our modulus. I've got to share that first time before
Okay. Now, I told you that the modulus gives you the remainder of any division. Okay? So, how many? 3 modulus 10 simply means that 3 over 10. 10 cannot go into 3. There's no way 10. So if we try to go into 3, it's going to be 0. 10 can go into 3 0 times. It can't. But then we are going to have a remainder of 3. So 10 goes into 3 0 times, remainder 3. Does that make sense? So that means that 3 modulus 10 is 3. Does it make sense? Anytime you think about modulus, think remainder. Modulus is remainder. So whether it's able to divide or not, as long as you have a remainder, that's your modulus. Very simple. Don't let this confuse you. So now we are coming to the second principle you are going to need. The first principle I taught you was that any number, no matter how big, modulus 10 gives you the last digit. Now I'm about to give you another one. Any single digit modulus 10 is the same digit. So 7 modulus 10. The answer is 7. Because 10 cannot go into 7. It will go into 7 0 times, remainder 7. So any single digit modulus 10 returns the same digit. Is that very clear?
Please, can you repeat that again? I think that's it.
Okay, very simple. No problem, no problemo, no problemo. This is what I'm talking about. Let's do some divisions here. 3 over 10. Let's do 17 over 10. And let's do 114,326 over 10. All right. What's this answer going to be? It's going to be 0.3, right? Now, when we look at this division, it's simply saying that 10 into 3. How many times will 10 go into 3? We cannot divide it, so the answer is going to be 0. So 10 goes into 3 0 times, and then we have a remainder of 3. Okay. Now, let's do 10 into 17. 10 goes into 17 1. Then we have a remainder of 7. This goes into this some number of times. If I take my calculator right now, I'll be able to tell. So this is probably going to go into this 1. So 10 into 114,326. 10 is going to go into this 11432 times. And then we're going to no, forget about this math. I'm probably not getting it right. But if I take my calculator, I'll get it. And the principle I'm trying to teach you is that 10 goes into this, and then we're going to have a remainder of a single digit, which will be the last digit, which is 6. Okay. So these ones are very easy, but this is what I was trying to explain to you. Any single digit modulus 10 equals to the same digit. Does that make sense now? So 3 modulus 10 is equal to 3. Any single digit modulus 10 equals to the same digit. Does that make sense? Can I proceed?
Yeah, it does.
It does. One more thing. Let's say 20 modulus 10. What's the answer going to be? Anyone?
0.
0. Perfecto. You understand the modulus? We are going on to the next operator. Okay, lovely. Now, apart from the modulus operator, now you can see here we have the increment and decrement operators. What is the increment operator? The increment operator is simply +1. The decrement operator simply means -1. Very simple. I don't have to scream about it. Very straight to the point. So if I have a variable, let's declare a variable, integer variable. So I have int. Let's beef this up a little bit to like 48 so that you can see it. So I have an integer variable of age. Okay, I'm not assigning any value to it, so no value for age. Then I come and say that age ++. What I'm simply saying here is that when I come and print age, so I now come and say print. Okay, for the understanding, let me assign a value 10 to this. So the value of age is 10. Then I come and say age ++. Then I print f with my format specifier %d. Then I bring the age. Okay. Now when I print this in my output, I'm going to get the result 11, not 10, because this ++ operator over here has increased it by 1. So the increment operator, it is called the increment operator because it's going to increment by 1. So assuming I come and say age minus over here, then this value is going to be 9, because the minus operator or the decrement operator reduces by 1. But then there is something more I need you to know. You can either bring the operators before or after the variable. Okay, so this is before. Now this is also going to print 11. However, in code implementation, this is going to be a little bit technical, but you're going to understand. Let's run through the computer's memory. Assuming we are trying to execute this code, let's run through it. Okay. Now we declared a variable called age, and we assign the value 10 to that variable. Then the computer comes down and sees that there is an increment operator here, and the variable is age. So the computer is going to add the value to the age before it prints. So age is going to be 11 By the time we are about to return the variable, age is already 11. Now, but if I bring this operator after the variable and I say age plus plus, the computer first recognizes the value of age as 10. Then it adds 1 to it. Let me delete it. But then if I bring it over here, by the time the computer is about to recognize the variable age, in the computer's mind, it is 11, not 10. I'm going to go over that again. The value of this age variable is 10 in the computer's memory. Now, when you bring the operator before the variable, by the time the computer is about to contact the variable age over here, it is already 11. But if I bring the operator after the variable, then the computer is going to recognize the age variable as 10 before it will add 1. Is that very clear? Or should I go over it again? Or I should just go on. When we come to the practicalities, they are going to see the implementation of it. So I'm just going to go on. And it works the same way for the minus, minus, and then the ahead of it or behind it. Very simple, straight to the point. So we understand the modulus operator, we understand the increment operator, and we understand the decrement operator. Straight to the point. Just go ahead with your question.
Yeah, so with an increment,
Mhm.
you want to increment it by 2.
It does-
Plus, plus, plus 2.
It doesn't work that way. The increment operator adds only 1. So assuming
Cool. Where they added
plus plus 2. So assuming you want to add,
maybe another 2.
no, it doesn't work that way in C. And it doesn't work that way in JavaScript too. And I've not seen it work that way in Python. So I'm really wondering. But then if you want to add, let's say you want to increment the value by 2, it's simply you go age plus 2. Very simple. Age plus 2. Then you add 2 to it. Or age plus 1 is actually the same as age plus plus. So the increment operator actually adds 1. It's age plus 1. But then the right way to do it is plus plus. That's it for operators. Now, we've done plus, minus, multiplication. The multiplication is asterisk. So in C programming, when you want to multiply, use asterisk. You want to divide, use forward slash. So very simple, straight to the point. But there is one more thing we need to know, which is the equal to. I've not spoken about the equal to, but we already know the use of the equal to. The equal to is called the assignment operator. It means you're assigning a certain value to a variable. You are assigning a certain value to a variable. You are going to see the importance of the equal to operator as we proceed. What's the time now? It's currently 8:40. God, we don't have time. Okay, so I'm going to go and talk about logical operators. Okay, so now I've finished with arithmetic operators. I'm done with arithmetic operators. I'm not coming back to arithmetic operators again until we are going to apply it in solving questions. All right, now let's go and talk about the logical operators real quick, and then we'll move on. The other ones, you don't need them now, so just forget about them. I have notes on them though, but you don't need them now. So let's talk about the logical operators, and then we'll move on to probably functions. We did functions yesterday, so I'm not going to talk about that a lot. Now, look at these 3 symbols carefully. There is a end, ampersand, ampersand. And there are these 2 vertical lines, and there's the exclamation sign. Okay? These are the logical operators. Very simple. But before we talk about the logical operators, we already know, so let me use another color. Let me use yellow. You already know what this means. Less than, greater than, equal to. You also know less than or equal to. You also know greater than or equal to. Very simple stuff. So you know that 5 is less than 2. You also know that 10 is greater than 9. You also know that 10 is equal to 10. You also know that 10 is greater than or equal to 10. In school, when we were being taught the greater than or equal to sign, this was how we wrote it, greater than or equal to. But in programming, you don't have this. You can't write this. So if you want to write greater than or equal to, this is how you write it, greater than or equal to, less than or equal to. And then we have another one, which is 2 equal to signs. This, in your mind, you simply read as is. Okay, so 10 equal to 10 simply means 10 is 10. Very simple, no confusion, very simple. 9 is 9 simply means 9 equal to 9. And this you see over here is known as a comparative operator. They compare values. Before, the reason why I'm teaching you this before I go to the logical operators, because we are going to compare values. So 5 is being compared to 2, and we know that 5 is less than 2. 10 is being compared to 9. 10 is being compared to 10. We know that 10 is greater than or equal to 10. Very, very simple. No confusion. Very, very simple. If you have any question,
Yeah, I want to clarify something. The equal to,
yes,
can we also say that it also means exact? Like,
you can say that.
yeah,
You can say that. You can say that. It's exactly as the other value. So the moment you use equal to, then you are dealing with an exact value. Very, very important. Yeah, go ahead.
We use equal to, when we are using it like the way we use it in mathematics.
Comparative. Yeah.
We use the equal to only one, as we already know
In mathematics.
We are assigning
the value to it. Straight to the point. You don't have no confusion about that. Very straight to the point. Very straight to the point. So now we're about to go into some sweet stuff, yet technical. So I need you to pay attention here. You're going to need this. All right. Now the logical operators. This one is called the logical AND. This one is called the logical OR. And this one is called NOT operator. So watch this carefully. 1 is 1. I'm trying to say that 1 is equal to 1, and that is true. Is that true or false? Anyone can speak.
True.
That is true. You're with me. Then I'm going to bring the logical AND. Okay, logical AND. And I'm also going to bring another condition, that 5 is less than 2, which is also, is it true or false?
False.
Okay. So now you're realizing that we have a condition over here which is true, and we have a condition over here which is false. All this you see over here, because of this logical AND operator, is going to evaluate to false. Okay, so whenever you use the logical AND, it means both conditions must be true. Both conditions must be true. If one of the conditions is false, everything is false. So the reason why all this we evaluate to false is because one of the conditions ended up as false. Very simple. Now I'm going to change this condition to true. Then I'm going to say that 2 is less than 5, which simply means that now this value of mine is going to evaluate to true. Then at the end of the day, this entire equation is going to evaluate to true. Very simple. But now, listen to this carefully. I'm going to change this operator and make it the logical OR. The logical OR. Okay? So let's say that instead of the logical AND, I now bring the logical OR. This is true. 1 is 1. Very true. But 2 is not less than 5, which means that now we need to cancel this. This is absolutely false. It's a lie. 2 is not less than 5. However, because I use a logical OR operator, everything will evaluate to true. So for the logical OR, if one condition is true, then that means that everything is true. Oh yeah. Sorry. You notice that? Very good. It means that you are paying attention. I like that. So 5 is less than 2. Yes. So you understand what I'm trying to say, right?
Yes.
Wonderful. So we don't have a problem. Now that is with the logical AND and the logical OR. Let's talk about the NOT operator. The NOT operator negates anything you give to it. If you give true to the NOT operator, it's going to negate it to false. If you give false to it, it's going to negate it to true. All right. So let's try it out. So I'm going to say that I'm going to give a condition, and I'm going to say that 1 is equal to 1. This condition is absolutely true. Okay. But when I now come and say that, put an exclamation sign in front of this thing you see here immediately is going to become false. It means that I have negated what is true. Assuming I gave it a condition which is false and I brought this, it's going to immediately become true. So this simply means not. And we are going to see how to use it in a minute. Okay? Because I'm going to make us use it to solve one of the ALS tasks, because it was a requirement in solving the task. So let me get rid of all this, and then let's try our hands on something. Okay. You are going to vote. You are going to vote. Before you vote, you must be 18 years or older, 18 plus. But then there's another condition. You must be a citizen of that country before you can vote. Okay? So me, I'm a citizen of Ghana and I'm 18 years plus. All right? So I'm going to say that so you're supposed to write a code in an American job that you have been given. You've gotten a remote job, and your company is requiring that write a code that will allow people to vote, or that will disallow people to vote based on whether they are citizens or whether they are 18 years or older. All right. Now, how are you going to write this code? Now, you first of all have to ensure that both conditions are met. So you are going to write a code and say that if let's first create a variable. Now, the thing we have learned is what we are using now. So we're going to declare a variable called age. Okay. Then let's not give any value to it. Let's just leave it empty. And then we're also going to declare a boolean. I'll talk about booleans in a bit. Boolean simply means true or false, true or false, true or false. All right. So let's say something. So we're going to say that if the age, what's wrong with my pencil? If the age is greater than or equal to 18. Now, watch this. Watch this. Which logical operator am I going to use? Because I need two conditions to be true. Watch this. So if the age is greater than 18 and, listen to this carefully, and, so I'm going to use my logical and, because both conditions must be true before everything values to true. So if your age is greater than 18 and citizen is equal to true, I put it in bracket, then I'm going to say that print f u, my pencil is not right, you know. I'm going to say that printf, what's wrong with my pencil? Printf, you can vote. Let's just bring this down a notch. Great. All right. Then I'm going to say that else print, you cannot vote. So you realize that this condition that I've given over here, age must be equal to 18 and citizen must be equal to true, or else you cannot vote. But assuming I didn't use a logical and I brought this logical or over here, then that means that if any of the conditions end up as true, you're going to your code has an error, because someone may be greater than 18 years but he's not a citizen. But because you have used a logical or in your code instead of a logical and, you're going to, the software that you have written is going to have problems, and then people who are not citizen are going to end up voting because your software has a bug. These are some of the practical applications of it. So now the logical AND ensures that both conditions are true before it allows you to proceed. But the logical OR says that if this is true or this is true, you can proceed. So this is basically how it works. Else, so we can even switch this up and say that we're going to write a code that checks your bank account. If you have a certain threshold of money in your account, you can withdraw, or else you cannot withdraw. These are control, like very simple and straight to the point. So in order not to waste a lot of time here, I'm just going to leave.
Yes.
Okay, let me go and see what's happening here. Nothing in the chat box, right? Great, there's nothing here. We have Bernice, we have Felicia, we have Ernest, we have Inshira, we have Ishmael, and we have Galileo. Great. The great 8. All right, okay. The big 8. All right. So let's go and talk about if-else statement. If-else statements are, it's too simple that we shouldn't even talk about it. So instead of talking about if-else statements, I think I should rather talk about while loops and the others. But we need to understand everything. So let me just run through it very quickly. We don't have a lot of time. So let's talk about, let's crash all the control flow into one. The if-else statement says that if you already know how to write conditions now. So if this condition is true, do this. I'll bring a curly braces. Do this. Or else, if this is not true, so we just bring else, do that, because this is ended up not true. Very simple. This if-else statement. But then you can have several conditions. So we can also come and say that another if-else statement. If this condition is true, then do this. Close my curly braces. Else, what is wrong with my pencil? Great. Else, if this condition ends up as true, then you bring your curly braces, do this. You can go on and on and on and on and not end. Else, if this condition is true, come on, do this. Okay? Then you finally come and end it with else, do this final thing. So these are if-else statements. Very simple. Nothing complicated at all. These are if-else statements. Okay? Now, let's go and talk about another one. We have something called a loop. No problem. Before I go and write something, I need you to keep this acronym in your head. ICU. Like you are in an ICU, intensive care unit in a hospital. You are in an ICU. Whenever you are going to write a loop, you need an ICU. Number one, the I simply means initialization. Initialization. The C simply means condition. And the U simply means update. You get it? No problem. Very, very simple. So we are going to write a loop. The syntax for writing a loop is that you bring the statement for, you bring a parenthesis, you bring your initialization, you bring a semicolon, you bring your condition, you bring a semicolon, you bring your update, and you close your semicolon. I mean, you close your parenthesis over here, then you open a curly brace, and your code comes in here. Very simple. This is a for loop. So we're going to say that for this, if this condition is true, do this.
If you're writing on a board, then we are not.
Oh, you're not seeing the board?
I was about to say same, yeah.
Oh, that's terrible. I was actually writing on the board all this while. So why can't you see it? Or can you see me?
Yeah, I think we can see the board now. We can see you trying to push to the board.
Okay, do you see the board?
You see what is written now?
Yeah, we
Like,
see the
you're
board
right.
now.
Oh,
See
then
the board.
it's probably it was a network issue. But can you see me moving around? Can you see me writing on the board?
Yes,
That's good.
I'm doing ashukri control the floor. I think the issue is with my pencil. There's something wrong with my pencil. Okay, no problem. Let's get rid of this. And sometimes too, my recording software, when it's taking a lot of the RAM of the PC, it starts misbehaving. Now, I'm about to show you something. Let's go and code. All right, let's go and code. We created a file called bernice.c. I wanted to use this to show you a few things, but then let's forget about that. And then let's do ggd caps G. I just clear everything at the same time. And then go into the insert mode again. Now, we're going to write a function. So let's include, as usual, you know this, our standard input output h. Can you see? You can see now, great. So let's open the code block. Then this function is going to return 0. Right, we're about to write loops. But before we do that, let's declare some variables. Let's declare int. Let's say we want to print numbers. So let's just say numbers. Numbers, okay? Then for the variable, I don't want to assign any value to it. We're about to write a for loop. Assuming I want to write numbers from 1 to 100, I cannot come and say int number equal to 1, int number equals to 2, int number equals to 3. So that is why the programmers invented loops, so that you can do all this at the same time. So now I want to print a number from 1 to 100, and I can do it in just one statement of code. So we can use a for loop to do that. We're going to say that for, look at the syntax of a for loop. For, when you bring your parentheses, okay, then for our numbers, we are using the same variable we declared over here. So for numbers, now remember ICU, intensive care unit, ICU. I'm saying it over and over for it to get into your soul. We need our I first, which is the initialization. So let's initialize our number somewhere. You can initialize it from anywhere, but we are trying to print from 1 to 100. So definitely we initialize it at 1. That's where we want to start from. It's our starting point. Remember I told you bring your semicolon. Then the second thing is C, ICU. The second thing is C. What is the condition? Our condition is that our numbers variable should be less than or equal to 100. Bring your semicolon. Then we are going to use one of the operators I taught you right now, which is the increment operator. So numbers plus plus. Very simple. This is a for loop. Very simple. So over here, all we are saying is that for numbers, start at 1. Then the condition is that numbers should be less than or equal to 100. Then next, you want to say that increment numbers. Increment numbers. Very simple. No stress. Very simple. Then when you are done, you open a curly brace for your for loop. Let's open a curly brace for our for loop. Then we're gonna, what's our loop supposed to do? We want it to print f. What is the format specifier for an integer? %d. So you bring your format specifier in quotation marks, you bring the comma, and you bring the name of your variable. You end it, and then bring your semicolon. This is a for loop. No confusion anywhere. No confusion anywhere. Okay? So I'm gonna exit this, and let's run this code, and let's see what we get. So let's exit this. Let's ls and see the file we have here. Our only file here is ben.c. So we are going to compile this with gcc ben.c, and I enter. Now when I ls, you're going to see that I have an executable file called a.out. Yesterday we spoke about compilation. I'm not going to talk about compilation. If you have any question on compilation, we can talk about it later. So the way to execute an executable file is /, then the name of the executable file. So a.out, and I execute the file, and let's see what we get. So it's working. You can see that we have been able to print all the way from 1 to 100. Anyone got a question? Galileo, I think you got to mute your feet. Okay, so with just one for loop, you realize that I've been able to print 1, 2, 3 all the way to 100. Very simple, very simple. Let's make it look a little good. So let's vi ben.c and let's go into it and let's see if we can just put some comments in there. So let's printf %d and then give it some comma and space. All right, and then let's print it on the new line. The syntax for a new line is \n. Very simple. Now let's exit. Now let me teach you something here. if we were writing in a language like Python or JavaScript, the moment we go and modify our file, we don't have to compile it again. We just modify it, run it, and it goes. But C programming is such that the moment you edit your file, you have to compile it again. You have to compile it again before you can execute it, or else the modification you have made won't show. So any modification you may make in a C program, you need to come and compile all over again. So let's compile all over again. So GCC, our file is ben.c. We compile it. After we compile, an automatic executable file with the default name a.out is going to be created. Assuming we didn't want to compile with the default name a.out, they would have just said GCC, the name of a file, and we'll output it to we'll output it to any name we want our file to be. Let's say we want our file to be called Leo. So I enter. Now the executable file is not going to be called Leo. So when I ls, you're going to see Leo over here. That's our executable file because I told the system that make my executable file called Leo. So now I can execute Leo. Okay. And then you're going to see that now we have 1 printed, 1 to 100 printed, and each of them is on a new line. And it looks more beautiful than it was before. Very simple. This is a for loop. This is a for loop. Now I'm going to go back into the file again. Let me clear my screen. The file is ben.c. So I'm going to go back into the file again, ben.c. Now, just give me a moment. And then let me just give myself some syntax. Good. Let's make this go down a notch so we see everything a bit nicely. Now, this is a for loop. Very simple. So you have to ensure that the condition becomes false at some point. If you don't make the condition become false, the thing will keep running and running and running until you run out of memory. Let me teach you something. So we've spoken about a for loop. So can you see the board?
Yes, please.
Great. I thought when I switch to the board, so we've spoken about a for loop that for initialization, condition, and update, do this. Very simple. Now let's go and talk about a while loop. This is a syntax for a while loop. You're going to see that while. Come on.
For we could go back to the syntax.
Yes.
Yeah. With the update.
This one, yes.
So let's say I just want to update on my question I asked.
Yes, yes, go ahead.
So if say we wanted to print only feeding lines, you would have to touch the update. That's where you have to go. Right?
No, not the update.
Okay, then hold on. Let me.
Okay.
This update. Say if we make the update number plus 2, what happens to the code?
Let's try it out. We are scientists, so we can experiment. So the best thing we can do is to try it out and see what we get. So let's do numbers plus 2. Like this, right? Like this, right?
Yeah.
Great. So let's go and compile this and then let's see what we get. So let's GCC and then the name of our file. Let's output it to Ernest, right? Ernest, right?
Yes.
Yes, I'm talking to Ernest. So I'm going to go in. Now look at this. It says that we have an issue in there. -e or -x. Hold on. Is it the way I compiled? So let's do it again. So we're going to GCC the name of our file. We're going to output it to Ernest. Now look at this carefully. It says that the expression result unused. And look at where it's pointing out the error. It says that we have a syntax error in here and it's pointing to this operator that you cannot say numbers plus 2. I don't know if it's going to work in some other programming language, but for what I've seen so far, I've not seen it in Python, I've not seen it in JavaScript, but I've seen it in, I've seen Python use ++, I've seen JavaScript use ++, I've even seen C# and C++ use ++, Java also uses ++. So that's how come when you were saying, I'm not too sure about that, I'll have to confirm. But then so far,
You can actually
in Python,
they are just
the initial number. Wow.
Let's say when you have the initial number of
Wow. So it's like it's gonna go incrementally that way.
Yeah. So it's not
Wow.
be a given number, but just going to increment
By 2. Well, that makes sense. That makes sense. I'm
But
gonna.
that syntax works in Python, right?
Yeah, but if you want a given number, that means you have to initialize let's say from 0. That's how you have to get the number. Sort of.
That's in Python. Yeah, I get it.
Do you know what I'm thinking? The numbers plus 2, can you put it into brackets for us to see whether it will work?
Why not? Let's try it out.
And possibly put some space in it.
Whatever you want. We're gonna try everything. We're gonna try everything. Just give me a moment. Oh, come on. Oh, come on. Just give me a moment. Sorry. It helps me work easily. Okay, so now what we're going to do is that we're going to put the +2 in parentheses. Is that what you said? What should I do to it?
Numbers plus 2, the last one.
So everything in parentheses like this,
Yes.
like this, like this.
Yes, please.
Okay, so let's execute this and see what we get. So let's GCC the name of our file, and then we output it to Felicia or Inshira. Who spoke? Felicia.
Yeah.
Okay, we're going to output it to Philly. All right. There is a problem. So let's go try another one. Someone was also saying something else. So let's go back to our file. So what else were you saying that I should do? Let's try it out. Let's try that one out and see if it works. So number space plus space 2, like that. Great.
The brackets to go away.
So let's take away the brackets now. Great. And let's go try and execute that. So we're going to GCC the name of our file. Let's output it to Ernest this time around. Enter. Same thing, same thing. So perhaps it doesn't work in C, but then it works in other programming language. So when we are done with this session, I actually take my time, and then I'm going to try it out in Python.
So how about, let's say, I don't know, excuse me.
Go ahead. Let's try it out. So let's via the name of our file, and then let's try it out. So we're gonna. If I was working in VS Code, this would have been so easy. Man, I don't even know why I'm working. You know what? Forget it. Forget about this. I don't even know why I'm doing this to myself, honestly. I don't know why I'm doing this to myself. Come on. It's because of the ALX training. That is why. Because why am I? Yeah. Actually, I actually know those shortcuts. My fingers are not used to them. My fingers are not used to them at all. So let's work in VS Code so that things become easy for me. I don't even know why I'm punishing myself using VI. Come on. All right. So what did you say I should do?
So let's say when you were that, let's say
so numbers equals numbers equals plus 2.
So numbers plus equal to 2, like that.
But the plus
plus equals 2, yeah.
Like this.
No, it's equal.
Yeah.
Oh,
plus equals. Yeah. So
that's it. Okay. Oh yeah, this is actually also a kind of operators, and we're going to see that in a bit.
So I think it will increase by 2. Let's try down.
So let me run this code and let's see what we get.
Okay.
So wait, it worked. This actually worked. So let's see where it started from. It started.
Yeah, so in Python, I think I'm actually use that one for loops.
So this is 1 3. This is 1 3 5 7. So it's incrementing it by 2. So assuming we initialize this as 0. So let's initialize as 0, and then let's run the code again and let's see what we get. So we have from 0 it jumps to. It actually jumps to 3, 5, but we initialize from 0. So no, we change the initialization to 0.
I don't understand why the other one didn't work, because numbers plus equals to is the same as numbers equals to numbers plus 2.
Exactly.
Because there was no space between the numbers and the plus.
So why don't we try it again? Yeah, that's also going to work because it's a kind of update. But the one that I wasn't really sure of was the plus 2, like numbers plus 2. Like the way, yes, an operator. But then the one that didn't work was what? Numbers
plus 2. I don't know if it's because there was no space between the plus and the numbers.
So let's try it out. And let's run this code and see what we get. See what it gives me. So do you know what's happening? Look at it carefully. We have an infinite loop. So this is what is called an infinite loop. It's running because the update is going to keep going and going until we run out of memory. So it's going to run.
So why are we getting an infinite loop?
But the reason why we're getting an infinite loop is that so let's say numbers plus 2 is our update. Hold on. The condition is that the number should be less than 100. We're not supposed to get an infinite loop. Hold on. Let's go run this in the terminal. I want to be really sure of this. So let's run.
Sorry, could we?
Go ahead. I'm listening. Why not? So we see
so the numbers plus 2 means that we are initialize
as 0.
Numbers as 0.
Yes. Then we came to say that numbers should be less than or equal to 100. That means I cannot go beyond 100. And now we came to say that numbers plus 2. So it shouldn't be an infinite loop.
Zeros. If it were to be numbers is plus or plus equals 2, it will have added 2
To the previous number. It would have updated it.
That is not updating.
Okay, now I get it. The plus sign is only used to add values of variables. So if we were to be adding two values, we would have added. And if we were to be adding two variables, we would have added.
Okay.
And because we are adding a variable and a value.
And the value.
That's why it's not working. Yeah.
So it means that I get it actually.
You assign a value, you are adding a value to the variable.
Exactly.
Exactly. You add a value to the, that's why that one works. And this one can't work.
It makes perfect sense.
Yeah, that's perfect. Yeah.
It makes perfect sense to me. I agree with you too. It makes perfect sense to me. Wow, that's wonderful. So you actually learned something new right now. I have learned something new. So I wanted to go run this in the terminal, but I think the explanation that Felicia gave is just perfect. So let's try and change these loops. Let's run some other loops and see what we get. So let's run a while loop. The way to run a while loop is to say that while a certain condition is true. So let's say while this condition, let's bring a condition that's forever true. So while 1 is less than 5, what should we do? Let's print something. Let's print Felicia is smart. Okay. So I'm going to run this code and let's see what we get. So you see that we have an infinite loop over here because I didn't give a terminating condition. Okay. So the thing is going to run and keep running and run and run and run and run. I'm actually scrolling. So if you look at the scroll bar, you can see that I'm actually scrolling down. If you look at it carefully. I'm scrolling down, but I keep printing and printing and printing. So there's no end to it. So this is what is called an infinite loop. I just got to get out of here because I'm going to run out of memory. Because when I initiated the while loop, I didn't give a terminating condition. So the while loop works this way. That was what I was trying to explain. While, then we bring our condition. Then we say that while this condition is true, do this. This pencil is just misbehaving today. So let's go and write a while loop and then bring a condition that terminates it. So to do that, let's try and initiate a count variable or any variable at all. Int count. So create a variable called count. We're going to say that while count is less than 5, print Felicia is smart, and then we are going to increment count over here. So let's just say something like count plus plus. And let's run this code and see what we get. I didn't bring a semicolon, sorry. So after this, I'm supposed to bring a semicolon here. So let's run this code and see what we get. So this time around, we get Felicia is smart printed 5 times because we brought a terminating condition. At some point, our condition is going to become false because we are incrementing count over here. Please, I hope that makes sense to us.
Yes, no, another question. So
Yes, sure.
when
Should I go back to the code?
no, it's not about the code at all. It's,
Okay.
I just want to know when and when not to use the while loop
Mhm.
or
There is this course that I will advise all of us to take. Data structures and algorithm. Data structures and algorithm. That course is not necessarily based on any programming language at all, but it is based on knowledge, logical reasoning, and coding structures. And to give you an idea of when do I use an if statement, when do I use a while loop, when do I use a for loop, when do I use a do while loop. So now, for me, there's a rule that I work by. As long as it's a conditional, it's an if else statement or a nested loop. Sorry, if this, do this. If not this, do this other thing. If else, don't think twice. Then, if it is something that's going to be a repetitive task, we have to do it over and over and over again. The answer is straight to the point. For loop or while loop. But the question is, when do I fall on a for loop? When do I fall on a while loop? Whenever what you are printing is a pattern, for loop. Don't think twice. For loop. Anytime you have to print a pattern, don't think twice. For loop. So for instance, I'm supposed to print 1, 2, 3, 4. 1, 2, 3, 4. 1, 2, 3, 4. No, why don't we rather go and use one of the ALS questions to be able to understand this? So I think in one of the projects, this is what functions. Let's go see one of the see our projects to do. This one is doing 2 days and this one is doing 4 days. Chai. And I'm here talking to you guys. I won't go and focus and do it, Chai. uh, but at least I have 2 and 4 days, so let me just enjoy while I can. Okay, so let's go to if else because I saw a certain pattern question over there. Let's scan through and see if we can see any pattern question. Yes, I see a pattern question. So anytime you see a pattern like this, you realize that it's printing a pattern for loop. You don't even think twice about it. It's a for loop. Look at this. This is a pattern question for loop. This is a pattern question for loop. So anytime you're printing patterns for loop or a nested for loop, but anytime the while loop is more flexible and it's more of like the while loop doesn't go, even though it's like the for loop, but the while loop, the termination of the while loop is faster than the termination of the for loop. If you are trying to do this with a while loop, it's going to take you some effort. But a for loop can do this straight to the point, very easy. So let's try our hands on one of the pattern questions and let's see how to use a for loop to do it. Let's try. I think this is rather simple. You're supposed to print from 1 to 89. That's quite straight to the point. So let's take a more complicated one so that we can apply the things that we have learned. Let's see this one. Let's try and do this advanced task because it's going to be a very complicated one. So that we'll use that to try and understand everything we've done so far. Are you guys with me? Or I've lost you.
Yeah.
Okay, just realizing that you're here. So we're going to solve one of the tasks together. We're going to do it together. Then let's solve this task. We don't have time. It's currently 9:27. We've gone way beyond our time. But then let's solve that task and solve another one. Then we'll call it a day. Let's try and do it. One that write a program that prints all possible combinations of two digit numbers. The numbers should range from 0 to 99. The two numbers should be separated by a space. All the numbers should print with all the numbers should be printed with 2 digits. One should be printed as 0, 1. The combination of numbers must be separated by a comma followed by space. The combinations of numbers should be printed in ascending order. Let's call them A. Just a moment. So all I was saying was that we're going to solve this task that ALS gave to us because I'm trying to let you see the use of a for loop. But this time around, it's going to require the use of not just a for loop, but a nested for loop. That's very critical. So let's go try and understand it here a bit. So let's get rid of this. What is the workflow of a nested for loop? Because I took a break, I'm just trying to find my flow over here. So we say that for, let's try and initialize something at 0, okay? And let's say that our I, assuming we have already declared the variable I, let's say is less than or equal to 5, okay? Then we're going to say that our I plus plus. We'll open it, and then we're going to say that, let's say printf, let's say we want to print %t our I, %t, comma, we want to print our I. We close our loop with the semicolon. So this loop alone is going to print 0, 1, 2, 3, 4, 5, right? Because it's going to iterate all the way until the condition becomes false. I hope this is very clear for us. Are there any questions on this one? Are there any questions on this one? Are you with me?
Yeah.
Okay, I thought I had lost you guys. I need your responses so that I know that you're still here with me. Okay, so yeah, because of the way the network was misbehaving, I just need to know that you're with me. Now, for you to write a for loop is simple and straight to the point. You just bring your initialization, your condition, and then your update. But when you're writing a nested for loops, anytime you have to print a pattern question, you have to know that the answer is a nested, not just a for loop, but a nested for loop. All right. So we're gonna go, instead of writing the code that this loop is supposed to print, we bring another loop inside the loop. Okay. So we're gonna say that for, let's say we declare another variable called j. So let's say we initialize j2 as 0. Then the condition is that j should be less than or equal to 5. Then we say that j plus plus. Then now we open the code block for the inner loop. We open the code block for the inner loop, right? Now let's say for the inner loop, we want to print f. We want to print, let's say the format specifier, we want to print, let's let's print %dj. Okay. Then we close the inner loop, the code block for the inner loop, and then now for the outer loop, we now bring the statement for the outer loop. So we're gonna printf, let's say, a new line. I'm gonna explain the code execution for this in pseudocode so that you see how it works. All right, so let's run this in pseudocode and see how it goes. I'm gonna change the color. Let's understand the code flow, the code execution flow of a nested for loop. So we're about to run this loop. Now, we initialize the outer loop at 0. So the I initially is 0. Now we're now coming to say that we're coming to check the condition. I is not supposed to be. So I is less than or equal to 5. So the question that we're going to ask is that, is 0 less than or equal to 5? The answer is that yes, it is true. Then it's not going to go to the update statement immediately. It's going to come down to execute the code statement. But when it comes down trying to execute the code statement, it encounters another loop. Then it goes to check the initialization. It's 0. We'll come and check the condition. Is 0 less than or equal to 5? The answer is yes. So now we'll come down to execute the code statements of the inner loop. It doesn't go to the update statement immediately. So now, when it comes down to execute the code statement of the inner loop, it says that we should print j. The current iteration of j is 0. So now, let's start. It's going to print 0. Then when it is done printing the j, it doesn't come straight to the outer loop statement to execute it. No, it goes to the update statement of the inner loop. So the increment j was initially 0. So now j becomes 1. So we'll now come and check the condition. So in pseudocode, it's going to come here. Then we're going to check. Now j has become 1 because it has been incremented over here. So is 1 less than or equal to 5? Yes. So we're going to come down to execute the code statement. Print j. So now we have j is 1. Then we'll go and increment again. J becomes 2. Is 2 less than or equal to 5? Yes. Print j. Then we'll come and increment. J becomes 3. Is 3 less than or equal to 5? Yes. Then we'll go and increment. J becomes 4. Is 4 less than or equal to 5? Yes. So we print j. Then we'll go and increment. J becomes 5. Is 5 less than or equal to 5? Yes. Then we'll go and print j. We'll go and print j. Then I will come and increment again. J becomes 6. Is 6 less than or equal to 5? No. Our condition is broken now. So the loop is going to break. And then it's going to come to the outer loop statement. The outer loop statement says that print a new line. So then it moves the cursor over here to a new line. When the outer loop statement has been executed, it now goes all the way up to the update statement of the outer loop. Remember that the outer loop was initialized as 0. So it goes to the update statement of the outer loop. Then it increments the outer loop iteration. So the outer loop iteration, which was 0, now has become 1. We'll come and check the outer loop condition. Is 1 less than or equal to 5? Yes. Then we'll come down to execute. Then we encounter another loop. When it goes around and comes, the inner loop is going to start all over again. So now the inner loop is going to start from the initialization, which is 0. So is 0 less than or equal to 5? Yes. Then we'll come down, print j. So it's going to start all over again. Then the inner loop is going to increment. It becomes 1. Is 1 less than or equal to 5? So the inner loop is going to run its loop all over again. So 1, 2, 3, 4, 5. Then when the j now becomes 6, the condition becomes false. Because come and check, is 6 less than or equal to 5? No. Then the condition becomes false. So the loop is going to break. And then it's going to print the statement of the outer loop. So now we go around and come again. You're going to realize that now the outer loop was 1. When we increment it, the outer loop has now become 2. So we'll go and check, is 2 less than or equal to 5? You get the hang of it. So now it's going to come back down to the inner loop and it's going to print everything all over again. 1, 2, 3, 4, 5. So the inner loop will break and the outer loop will come again. Now the outer loop becomes 3. The inner loop is going to go all over again. 3, 4, 5. Then we'll go again. Outer loop becomes 4. We go 1, 2, 3, 4, 5. Then we go again. Outer loop becomes 5. 1, 2, 3, 4, 5. Then now the outer loop becomes 6. Is 6 less than or equal to 5? No. Then the outer loop will also break. After the outer loop breaks, now we come to the code, the rest of the code in your program. Now there's a pattern I want you to see. Are you guys with me?
Yes.
Yeah.
Is what I'm doing making sense or I'm talking to myself?
Really making sense.
You're confused. But someone says it's making sense. That was Galileo or Ishmael. Was it Ishmael or Galileo?
Well, it's making sense a little bit. Okay, maybe because I already told maybe, but it's making sense to me a little bit.
Okay. Felicia, it's very simple. All we are saying is that there's a loop inside, and the loop inside has iterations. That iteration of the inner loop is encased in an outer loop. The outer loop also has its own iterations. So it's like, this is what we are saying. If you look at it plainly like this, it has become too bad. Let's make it simple. It's very simple actually. What we are doing is very simple, okay? Now listen. This is a box, okay? I'm telling this box that run here and go and come 5 times. So this box is supposed to go and come 5 times, okay? So now this box will go and come 1, it will go and come 2, it will go and come 3, it will go and come 4, it will go and come 5. That is very simple. That's all about it. But inside this box, I have put another box, which is also supposed to go and come 5 times. Okay? So now this is the inner. And then this is the outer. Okay? So now, remember that I said the outer box should go and come 5 times. Then the inner box is also supposed to go and come 5 times. So now, forget about this. Let me cancel this. Let's start over. When the outer box goes and comes once, the inner box will go and come 5 times. Okay, so the outer has gone and come once, but the inner will go and come 1, 2, 3, 4, 5. That's the inner box. Then the outer will now go and come for the second time. Then the inner will go and come 1, 2, 3, 4, 5. Then the outer will go and come the third time. Then the inner will go 1, 2, 3, 4, 5. So for every journey of the outer box, the inner box does 5 times of the journey. So when the outer box goes and comes once, the inner goes 5 times. When the outer goes once, the inner goes 5 times. When the outer goes once, the inner goes 5 times. So assuming we said our condition is that it should be less than 3, then the outer box will go and come 0, 1, 2, 2 times. Because when it becomes 3, the conditions become false because 3 is not less than 3. So it will go and come 0, 1, 2. And assuming we said that inner box will also go and come 3 times, less than 3, it means that when the outer box goes and comes once, the inner will go and come multiple times. So for the 0 iteration, the inner will go and come 1, 2, 0, 1, 2. Then the outer will do the second one. Then the inner will do 0, 1, 2. Then the outer will do the third one. Then the inner will do 0, 1, 2. So for each journey of the outer box, the inner does all its journeys. For each journey of the...
So if I understand this well,
Mhm.
if a variable is less than a particular number, does it mean that it's not necessarily talking about the output, but rather the number of times we should print?
Exactly. When we are dealing with loops, exactly, you are spot on. When we are dealing with loops, we are dealing with something called iterations. Iterations. So whenever you are dealing with whether it's a for loop, whether it's a while loop, whether it's a do while, we've not spoken about do while loop, but not today. We've done too much. It mustn't jump up. So we have done for loop, and now we have done while loop. Whenever you are dealing with loops, know that you are dealing with iterations. So when you say the variable is less than something, you are saying that it should go and come that number of times. That is why it is called a loop. Very simple. Not complicated at all.
I get it.
You get it now. So,
While the outer
uh-huh,
one
uh-huh,
is meeting the first condition, on its way to go and print,
uh-huh.
it encounters another loop.
Thank you. Perfect.
And that loop
Mhm.
will keep, that loop will run until it terminates totally
Totally.
before the outer loop
Start the next one.
Okay.
Does it make sense? Very simple, actually. It looks complicated, but it's not. It's not.
Unfortunately, I have to take a leave of you. So tomorrow, same time, right?
Same time, we're starting at 7 tomorrow. I know we've taken a lot of time, but I mean, these things take time. They take a lot of time. So I don't even know whether we'll be able to solve the question that I'm trying to solve for it. And the funny thing is that this is the second project that ALX released for C programming. And imagine the amount of knowledge of the concepts you have to gather before you're able to solve something like this. That's why I'm saying that ALX is not beginner friendly. This is something not for beginners, but it's all right. Should I go ahead and solve this, or we should pause and then come and continue tomorrow?
Yeah, I think you should solve the questions tomorrow. I don't know what the others, but
That'll be perfect for me. I'm not being selfish. Yeah.
What of Felicia and Ishira and Ishmael? What do you say?
Yeah, I would say we should solve it now.
I didn't get the question.
I know.
But we can try it tomorrow. I think we all understand it.
This is what I'm going to do. I'm going to solve it now so that those who have to take leave of us will go. Then tomorrow, when we start, we're going to start from this question. So for those who didn't join these sessions, I'm going to put the recording on my YouTube channel. I actually have the recording of what we did yesterday on the YouTube channel already. If you've not watched it, you can just go. It's the latest video that I put there, and I already put the link in the chat box. So I'm going to put the recording of this one on the YouTube channel so that those who are not able to join will have to go and watch. Because tomorrow, the moment we come, I'm not going to go back to everything we've done again. And that is a problem that I had with the senior cohorts. Imagine all that we have done, Then tomorrow we come and somebody is asking about variables. It's like, it's not fair. It's not fair for us to keep going back like that. We're not going to make any progress at all. So the best thing to do is to go back, to go and watch the videos, and then so that we can pick up from where we left off. So tomorrow, if you want to take leave of us right now, you can feel free to do so. But then if you join us, okay, so let me share this link for yesterday's session. I'll just put it in the chat box. That's it. Go watch it. Okay, so those of you who have to leave us, feel free. It was wonderful having you here. And then for those who can stay for us to finish solving this question, let's use about 10 minutes to run through it, and then we're gonna just do it quickly. Okay, so let's try it out. We are supposed to print this pattern. Come here, where are you? We're supposed to print this pattern. We see 2 zeros, space, then another one, then comma and space, then another 0 0 comma. Then we see this going on. There is something that I need to tell you. Whenever you see a pattern like this, look at it carefully. Realize that this one is remaining the same. This one is remaining the same. Then this one has moved forward once. This one is the same. This one has moved forward to the next number. This is the same. This has moved forward to the next number. This is the same. This has moved forward to the next number. Do you see that these are iterations that are running? So this is an iteration. This is an iteration. You can see that a certain iteration is moving forward, while a certain iteration is standing at the same point. Do you see what's going on here? So this is a loop that is running actually. This iteration, so you realize that all the way from this point to this point, this iteration ran till 9. Then that iteration broke. Then another iteration, the second iteration picked it up. So this is the iteration of another loop. So the first iteration that was running was an iteration of a certain loop. And then this is an iteration of another loop. I know it might look cryptic, don't worry. Let's go try it out in code. Okay. So we have included our main.h, int main. Let's open a code block. Let's declare variables. Let's int number 1 and number 2. Okay. And our function is definitely going to return 0. Wonderful. Like I told you, whenever you see a pattern, you want to solve it with a for loop. So we're going to say for num1. What determines the initialization? The initialization is determined by the first number you see. It's starting at 0, so there's no doubt we're going to start at 0. Where are you? So num1 starts at 0. Then, what's the condition? Our num1 should be less than or equal to. Now, there's another trick that I need to show you. The outer loop runs the number of times there are rows in any pattern. Programming. Sheesh. Man, oh my. So, assuming I have this pattern, let's say I have this. Assuming I have this pattern, all right. The outer loop is going to run the number of times there are rows. Okay, so this is row 0, this is row 1, this is row 2, this is row 3. So this pattern is going to run the outer loop less than. This outer loop is going to run less than 3 times, or less than or equal to 3 times. Just give me a moment. Let me attend to someone. Okay, all right, no problem. I hear. No. All right, cool. Yeah, that's cool. Okay. Sorry about that. I needed to attend to someone. So whenever you see a pattern like this, the outer loop is going to run the number of times there are rows. So this is going to run less than or equal to 3 times. So the moment the condition becomes 4, this loop is going to break. Now, if you look at this pattern very carefully, you're going to realize that it runs all the way till 98. It runs all the way till 98. Because if you look at this ellipse sign over here, it means it goes all the way on and on and on and on till the loop runs all the way till 98. That means that the rows are going to be 98 rows, meaning that our condition will be num1 should be less than or equal to 98. Then definitely we're going to increment num1. So num1 plus plus. Then we open our curly braces for the outer loop. The moment we open the curly braces for the outer loop, instead of bringing the code statement, we now bring the inner loop. The inner loop before the code statement of the outer loop. So we're going to say for the inner loop conditions, which is num2. So num2 is going to be initialized at, now look at this carefully. Num2, if you look at this carefully, realize that while the first iteration is moving on and on and on, I wish they brought all the patterns so that I can explain what I'm explaining, I can tell you what I'm trying to say carefully. while this iteration is moving, the next iteration is the previous iteration plus 1. Let me say that again. The next iteration, the next loop is the previous iteration plus 1. Let me just solve it. Let me just go ahead and do it. So this is going to be num 1 plus 1. That's where we start the second loop from. We're going to say num2 should run less than or equal to 99 times. That's because if you look at it, you're looking at 99 over here. So the second loop, the inner loop runs till it's less than or equal to 99. And as usual, we are going to increment our num2, so num2 plus plus. We'll now try and bring the print statement of the inner loop. We're supposed to use putchar, but I've not defined my putchar function. So according to ALX, we're supposed to use underscore putchar. Now, before you use putchar, remember that you have to put it in a main.h file, and then you also have to define your putchar function. But I don't have all the time for that. So instead of using my main.h, I'm just going to call the standard library for the purpose of using the putchar function. Okay, so let me just use the standard library, standard input output.h, for the purpose of my putchar function. If I don't include the standard input output.h, it means I have to go and create my own putchar function, and that's going to be a long story. Yesterday we spoke about that, right? So today, just permit me to use the standard library. Maybe when we are solving it tomorrow, when we join the class, we're going to go the ALX way. We'll create our main.h, create our putchar function so that we can use the putchar over here. The putchar simply prints a character. So we're going to print, the first thing we're going to print is, we're going to print in single quotes num1. First of all, we're going to divide it by 10. Then we'll add it to its ASCII character representation. I'm going to explain this to you. Just give me a moment. Then we're now going to putchar again num1 modulus 10. This is an advanced tax anyway. And we'll add it to its ASCII character representation. Then now we're going to putchar again. Print. Let's see the pattern. We print first a comma. No, first a space, then a comma. Okay. So we're going to putchar some space. Then I'm going to putchar a comma. Okay. Then I'm going to putchar num2 divided by 10. I add that to its ASCII character representation. Then I'm going to putchar again num2 modulus 10. I'm going to add that to its ASCII character representation. This is 0. What do we have here? Okay. Let's analyze this very carefully. Let me get rid of this, so it doesn't look like it's a character. Good. Why is this giving me a syntax error? Num2 divided by 10. Oh, I used the backslash instead of the forward slash. Good. Are you guys with me?
Yes, please.
I thought everybody had left. It was left with just Felicia and Shireen. Okay, let's try and analyze this in pseudocode. What's going on? So first, definitely you have to include your header file. ALX will say you should use main.h because we need to define our own putchar function. But because I don't have the time for that, we are using the standard library so that I can use the putchar function. Okay, then this is our usual int main function, which returns 0 as usual. Then we defined two variables, int num1 and num2, because we are looking at a pattern of two variables. Then we initialize an outer loop. Then we initialize it as 0. We're saying that it's going to run till it's less than or equal to 98. Then we incremented it. Then we see that for the inner loop, the num2 equals to the num1 plus 1. We'll talk about that into detail tomorrow. Then the num2 should also run less than or equal to 99 because of the last number. Then our num2 also incremented. Then we came to putchar num1 divided by 10. Now this is where I need you to pay attention a little bit. Now look at this. In any programming language, when you divide an integer by an integer, the decimal portion will be discarded. So if let's say I divide 17 by 10, the answer is going to be 1.7. But because I've declared these as integers, the answer is actually going to be 1 and not 1.7. So the 0.7 will be discarded because they are integers. So if you want the 0.7 to be given to you, then you don't declare an integer data type. You rather declare a float or a double, because integers don't deal with decimals. So if I say int A, int B, and I say A is equal to 17 and B is equal to 10, and I divide and I get a decimal figure, the decimal portion will be discarded and thrown away. That is the rule of programming languages. So anything, let's say I divide and I get 2.8, the answer is going to be 2, because the 0.8 will be destroyed and cancelled. So the reason why over here we have to divide it by 10 is that one iteration must stay in the same figure while the other iteration is running and running and running. So if you look at the pattern carefully, usually in solving pattern questions, you have to analyze it. While this iteration, so see these figures as the put car. The first put car will print this. The second put car will print this. The third put car will print this. The fourth put car will print this. The fifth put car will print this. Now let's come to the next pattern. The first put car will print this. Second put car will print this. Third put car, fourth put car, fifth put car, sixth put car. So now we're going to, all the put cars you see over there are printing these characters. And the reason why I made the put cars plus 0 in quotation marks is that the put car function prints a character. ALS says you can only use put car. So for you to use the put car function prints only characters. So if you compute something and at the end of the day your result is a number, the program is going to read an error because the put car function is only supposed to print characters. So the ASCII way of converting numbers to characters is to add it to 0 in quotation marks. So assuming I compute something and I get the figure 5. 5 is a number, it's an integer, it's not a character. But if I want to convert it to character, then I need to add it to 0 in quotation marks. That is the ASCII way of converting numbers to characters. Just memorize it. Just let this one be in your head. Very simple and straight to the point. And the reason why I divided that variable by 10 for the first one is that any number divided by 10, like I told you, will give you the first figure and it will discard the decimal portion. And then any number modulus 10 will give you the last digit. So now what is happening here in this pattern is that the first put car will divide whatever iteration the system is in by 10. Then it's going to discard the decimal portion and give me the first part. Then the second put car is going to modulus it by 10. And then it's going to only give me the last figure. Let's break it down further. So assuming I'm printing, let's say the first iteration is in 1. So 1 over 10 is going to be 0. Actually, this is supposed to be 0.1. But because both of them are integers, this is going to end up as 0. So 1 over 10 in programming is 0. Very simple. Then let's say the iteration runs and runs and runs and runs. Then we are at iteration number 13. So 13 over 10. This is supposed to be 1.3. But the decimal portion will be discarded. So this is going to be equal to 1. So when you divide any integer by 10, it's going to discard the decimal portion and give you only the first figure. Now let's use the same 13. 13 modulus 10. Like I explained to you, we are only going to get the remainder. So 13 modulus 10 is going to be 3. Very simple and straight to the point. So now watch something. The first put car, assuming we are in iteration number 13, the first put car is going to give me 1 when I divide it by 10. So this first put car is the number divided by 10. Whatever iteration we are in divided by 10. So assuming we are in iteration number 13, the first put car is going to give me 13 over 10. The answer is going to be 1 because the decimal portion will be discarded. Then the second put car is going to give me that same number modulus 10. Okay, now when we do that, 13 modulus 10 is going to be 3. So we are going to have the pattern 1, 3. Watch it. Don't fight. don't be afraid. Just have faith. Let's break this down. Let's see if you guys are here. I've lost you guys because this thing is getting messy.
Yeah.
I like it that you're here. Thank you. Let's say we are running iteration number 13 to 20. Okay, let's run it with a division and see. So the iteration number 13 is going to, the first put car is number 1, whatever the iteration is, over 10. Okay, so assuming it's 13, it's going to be 13 over 10. And like I explained to you, if they are integers, so the decimal portion will be discarded, so it will be 1. Then the next one, the next put car says that the number modulus 10. So it's going to be 13 modulus 10. And the answer is going to be 3. So we are going to have 13. Okay, then we move to the next one, the next iteration, 14. 14 divided by 10 will be 1.4. The 0.4 will be discarded, so we are going to have 1. Then we come to the next put car, 14 modulus 10. Modulus only gives a remainder, so we are going to have 4. So it's going to bring 4. Then we move to the next iteration, 15. 15 divided by 10 is 1.5. The decimal will be discarded. So we're going to have 1. 15 modulus 10 is going to be 5 because for modulus we only get a remainder. So we're going to get 15. Next iteration, 16. 16 divided by 10. Now you get the hang of it. It will give us 1. 16 modulus 10, 6. Move to the next iteration, 17. 17 divided by 10, 1. 17 modulus 10, 7. Then move to the next iteration, 18. 18 divided by 10, 1. 18 modulus 10, 8. Next iteration, 19 divided by 10, 1. 19 modulus 10. So you see what's happening here. This is the pattern that I'm trying to explain to you all this while. Okay. You want this iteration to stay the same while this iteration is moving forward. I'm repeating that again. You want this iteration to stay the same while the next iteration is moving forward. So that is why this syntax you see over here is very important. You first divide by 10 so that that iteration stays the same throughout. And then the next one is at modulus 10 so that that iteration can keep moving forward. So let's run this code and see the pattern that we get printed. Okay. Now that's a lot of code, but let's start from the beginning. Geesh, ALX can be wicked. Why can they do this? So over here we see that we are printing 0, 0, and there's a character here it's not recognizing. Then there's a comma. Then we print 0, 1, and then there's no space. Okay, so let's go work on our code properly. So it means that we print the first one, the second one, then after that we print a comma instead of a space. Okay, and we don't use double quotes, it's a character, so we use single quote. So we print a comma, and after the comma we print a space like this. Okay, so let's run the code again and see what we get. Jeez, ALX. Amazing. Did I compile it? So I see 0, 0, and I see an unrecognized character here. Then I see 0, 1, 0, 0, unrecognized character, 0, 2. Okay, so the pattern is actually in there, but then we need to work on our commas and our spaces. Let me go inspect the pattern that we have with ALX. So I have 0, 0, space, put car, space, figure, comma. Okay, so let's go work on that. Let me see if you guys are still here. Yeah. So we have put car, space. We have put car, comma. I'm gonna take this and bring it here. Let's run the code and see what we get. Much better. Okay, so let's go to the beginning. Let's see what we get. Right, wonderful. So now I see that the pattern is beginning to work. So we see 0, 0, 0, 1, 0, 0, 0, 2, 0, 0, 0, 3, 0, 0, 0, 4, 0, 0, 0, 5. It's like the pattern is now in, but I don't see my commas. I don't see my commas after the second one, just like we have in the ALX pattern. So, I think I included it, but I don't know why it's not showing. So we have, oh, you're right. I didn't include it. You're right, Felicia, you're so smart. So now I include my comma. Now I run this code again. Let's see what I get. Perfecto. So now everything is just as it was. But actually, that's not exactly as it is. We need to include an if statement. Let's go to the beginning. Geesh. Man, oh man, that's a lot of numbers. Why would ALX do this? So I see 0, 0, 0, 1, the comma. And after the comma, I don't see space here. There's supposed to be a space after the comma before the next pattern. So it means that after the space over here, I'm supposed to put car another space. So I put car, and I bring a space, just like that. But if you look at it carefully, you realize that after the last numbers, which is 98 and 99, there's no comma. There's no comma. So that means that you have to give an if-else condition that if the number is equal to 8 and 9, don't bring a comma. So that is where the if-else condition comes in. So you can now come and say that, initialize an if statement. If num1 is 8, a logical AND, and num2 is 9, then just put car a space and not a comma. Let's run this code and see what we get. See if the last numbers will have their commas. So I see that the last numbers still have a comma. I see 98 and I see 99. There's still a comma here. You're supposed to exempt this comma. So let's work on the if statement correctly. So if num1 is 8 and num2 is 9, then just print a space. let me say continue. Tomorrow I'll introduce you to continue statement. Let me see what happens. So let me print it. It is the same. So 98, 99. My comma is still here. There must be something wrong with my logic. Okay. If number 1 is equals to 8 and number 2 is equal to 9, then let's exempt this code. This should work. I don't know why it's not working. I don't know why it's not working. I'll have to inspect it carefully and see why it's not working. If you guys know why it's not working, you can tell me. You guys are still here. I see.
Yeah, still here.
Yeah, amazing. You see that in the pattern, the last number does not have a comma. So that means that, let's inspect it. This is number 1 and this is number 2. So if number 1 is equal to 9 and number 2 equals to 9, then don't print a comma. So if number 1 equals to 9 and number 2 equals to 9, don't print anything. Let's run this code and see if our last figure exempts the comma. It's still there. We still have a comma here.
It won't work. It won't work because
Why won't it work?
in between the code, you still have 99 in there.
I still have 99 in there.
It's not the last number.
Hold on.
Yeah.
Wait, hold on. I'm making a mistake. Actually, we are not dealing with a single number. We are dealing with two numbers. So let's try it. Let's say if number 1 equals to the first number 98 and number 2 equals to 99, then continue. Let's run the code and let's see what we get. It's still there. We need to make it work. So if number 1 equals to 98 and number 2 equals to 99, yeah, it should work. So let's put car. We'll put car space. Let's run this code and see what we get. Well, my comma doesn't want to go away. It's still there. I'm tired. Tomorrow we're gonna figure it out. But at least just get the hang of what I'm trying to say.
Is it still there?
Yeah, the comma is still there. Let me run the code for you to see. It's still here. So our comma at the last 99. We're not supposed to have a comma at the last 99. And if statement is supposed to.
If number 1 is equal to 98,
That
and
is
if number 2 is equal to
99. That's it.
Mhm.
So we put car just space or nothing, then skip. But it doesn't seem to work. There must be some logic that I am missing actually.
you can't see the code.
You can see the code.
If number 1, yeah.
That's it. So let's say I put car, comma. No. Tomorrow I'll introduce you to continue. I'm supposed to actually continue. So I have to skip. Continue. Or else put car, a comma. And put car. There are too many put cars in this code. A space. Let me run this code and see what I get. I still have it there.
Still there.
Yeah, it's still there. We'll figure it out. We'll figure it out
So we'll
tomorrow.
figure that out. Yeah.
Tomorrow, I'm going to take my time. Tomorrow, we're going to hit pointers. But then we'll start from this point. So I'll try and edit this video and then post it on the YouTube channel. So that those who were not in the class and just go back and go watch it, then we can pick up from this point forward. We just brush up on what we've done already. And then we're going to pick up from this point.